most people, the expression unidentified flying object brings to mind images of interplanetary spacecraft. However, the theory that aliens exist has met with many objections. Some scientists will even say that it's nothing more than nonsense. According to them, if we consider the vast distances that separate the stars, it is ridiculous to think that aliens could be visiting us. For instance, if we look at the star that is closest to our sun, Alpha Centauri, we see that it is slightly more than 4 light years away from Earth. In other words, it is as far as light would travel in 4 years. Since light travels at a speed of 300,000 kilometers per second, we're talking about a distance of approximately 38 billion kilometers. That would be the number 38, followed by 12 zeros. Even if we could imagine an alien civilization capable of traveling at close to the speed of light, they would take at least 4 years to get to our planet and another 4 to get back home. And if they decided to trade in their spaceship for a car driving down the highway at 60 miles per hour, our intergalactic travelers would take 120 million years to cross the same distance. And to do what? To butcher a few cows in the U.S. Midwest? To kidnap a Boston postal worker? To gather a few samples of lavender in France? Let's get serious. We now know, based on certain criteria, that Alpha Centauri cannot have any habitable planets orbiting it. This means that if aliens do exist and are visiting our planet, they must have come from somewhere else, somewhere much farther away. But where could that be? We might be getting off track. It might not be as far away as we think. The speed of light might not be as absolute as astrophysicists claim, and somewhere else may turn out to be nowhere. The universe has by no means revealed all of its secrets. The UFO problem raises 2 questions with regards to aliens. First of all, do intelligent life forms exist in the universe? Secondly, do they have the means to visit us? In terms of biochemistry, life as we know it is like a cake recipe. Certain ingredients are required. Professor René Racine is considered by many as one of Quebec's leading astronomers.
Les experts, dont je ne suis pas, pensent que la vie...
I'm no expert, but they think that life is carbon-based, and only a mixture of elements such as carbon, nitrogen, oxygen, and hydrogen could produce life, or the level of molecular complexity necessary to generate life forms. Other combinations also exist. For instance, silicon mixed with oxygen gives sand, but it's far from being as malleable and fertile as, say, blood, for example, which is composed of carbon, nitrogen, and oxygen. Carbon, nitrogen, oxygen, and hydrogen exist everywhere in the universe. So all we need is the right conditions for these elements to combine, then increase in complexity and evolve into a life form.
Obviously, simply mixing elements such as hydrogen, oxygen, and carbon together is not enough to spark the complex process that produces life. Going back to our cake recipe, tossing a couple of eggs, some flour, and sugar into a bowl and mixing them together doesn't give us a cake. The mixture needs to spend a certain amount of time cooking in the oven at a specific temperature. In cosmic terms, the equivalent of the cooking process for this hydrogen, oxygen, and carbon mixture is referred to as planetary conditions.
We need to understand that the conditions required to create this biological or living soup are very precise. There's the time element, the stability of the planet's orbit, and surface temperatures. And it's hard to find ideal conditions where all of these elements coexist. We've known that for a long time. It makes us realize how incredibly unlikely it was for life, especially intelligent life, to emerge here on Earth. And yet, it happened. To be more precise, It's believed that a planet's surface temperatures must allow for biochemical reactions to take place. Therefore, they must remain within a certain range. They have to stay between water's freezing point and evaporation point, for example, since water is an essential element. And the orbit of the planet, or the object on which a life form might develop, must be very constant. Planets orbit around stars, just like Earth orbits around the Sun. And if the distance between the planet and its star varies over time, surface temperatures will change. Now you can see why we are so concerned with the effects of an increase in temperature on Earth's ecosystem. Even a change of 1 or 2 degrees can have a catastrophic result. To keep the temperature constant, it's crucial that Earth's orbit remain as circular as possible. Earth is always the same distance from the Sun within a 1% margin. That's just one example among several others. From our observations, we now know that when planets or other protoplanetary objects form around young stars, there is a dynamic of intense agitation. And it's not easy to explain how a solar system such as ours could have come about, in which there are 8 or 9 planets, if we include Pluto, whose orbits are nearly perfectly circular. So those are the conditions, and I've given you an idea of how difficult it is for all of those conditions to be present at once. It happened here in our solar system. There was a planet called Earth, just the right distance away from its star for the water to maintain its fertile properties. Water can be too hot or too cold. The temperature of Earth's water may not have been ideal at first. The Sun may have been hotter in the beginning. Mars might have had a relatively high surface temperature. There may have been arch biology on Mars. Who knows? The point is, it's very difficult to meet all of the conditions at once.
In the early 1960s, scientists were optimistic about the existence of extraterrestrial life forms. They used planetary conditions found here in our solar system as a model, believing that the same model must exist everywhere else in the universe. But recent discoveries of planets outside of our solar system have put a damper on their optimism. It seems that stable planetary systems are actually a lot rarer than we had thought up until now.
Establishing our level of knowledge or confidence is a question of statistics. In the 1960s and 70s, Frank Drake came up with a relatively simple mathematical equation that included the probabilities of each factor required for life to emerge. What is the probability that a star will have planets? What is the probability that these planets will have a stable orbit? What is the probability that the planet will be far enough away from the star? If we want to calculate the probability of communicating with extraterrestrial life forms, what is the lifespan of a civilization capable of communication? I recall at the time, we would multiply all of these factors by the number of stars in the galaxy, and the answer would be a few units. There would only be a few habitable planets where life could develop in our galaxy, the Milky Way. But back then, we were going on the supposition that all stars have planets, and now we know that's not true. There has been a lot of talk about discoveries of planets outside of our solar system. But we have to remember that the 80 or so planets that have been discovered so far were among 3,000 stars that were examined. This shows that it's not 100% certain that a star will have a planet. In reality, the probability is more like 2 or 3%. What's even worse, if we include in our probabilities the total number of planets discovered around stars, there are planets whose orbit is irregular or elliptical, or whose surface temperature varies between 100 and 300 degrees Celsius, not over a period of millions of years, but over a period of weeks or days. I would say that recently, over the past 5 years or so, the consensus has been that the creation of life as it occurred here on Earth happens very rarely elsewhere.
Produite très rarement à l'extérieur.
L'optimisme de Drake, au début, eh bien, était basé sur...
Drake's initial optimism was based on the fact that there are over 10 billion stars in our galaxy.
d'étoiles. Alors, à ce moment-là, bien, les chances qu'on en trouve quelques-unes...
At the time, it was believed that chances were pretty good of finding stars with planets orbiting around them.
Les planètes qui tournent autour de ces étoiles-là, eh bien, pourraient quand même être significatives. Mais
We have since discovered a lot of massive planets.
beaucoup de planètes massives,
But according to the basic criteria, these massive planets could not have formed close to their star.
massives-là, bon, bien, ne peuvent pas être formées près de leur étoile.
They would have had to form far away from the star, like Jupiter did in our solar system.
Distance,
Jupiter is 5 times further away from the Sun than the Earth is. So these massive planets must have moved closer to their star over time. At first, we wondered how that could happen. But after much study, we realized that it was relatively easy for a planet as big as Jupiter to evolve and then migrate from the position where it was formed to a new position closer to the star. Which makes us wonder, if this is possible, then why is Earth still in the same place where it is now? If Jupiter had moved closer to its star, like the other massive planets that we observed, then Earth wouldn't be here anymore.
de leur étoile, alors bien, la Terre ne serait plus là.
Now we're asking ourselves the question, why are we still here?
On pose plutôt la question inverse. Pourquoi est-ce que nous sommes ici? Et puis il semble que Jupiter serait un cas...
It seems that Jupiter is different from a lot of the planets that we discovered outside of our solar system.
beaucoup des autres planètes extrasolaires.
The good news is that once all of the conditions have been met, it's easy for life to spring forth. In 1953, Stanley Miller, a young biochemistry student, took a sphere and filled it with the gases that were present on Earth 1 billion years ago. He then bombarded the sphere with strong electrical charges, recreating Earth's original climatic conditions. At the end of the experiment, Miller observed that his mixture had become enriched with an additional substance: amino acids, the building blocks of life. Miller's experiment proved that it was possible to create life from inorganic matter. As for the transition from organic life to intelligent life, it was just a question of time and ability. To help you understand this long process, let's imagine the Earth's entire evolution reduced to the length of a 24-hour day. If we start with the formation of the planet Earth at 12 a.m., then life does not appear until 5 a.m. The planet takes all day to develop, and the first mollusks do not appear until 8 p.m. Dinosaurs don't show up until 11 p.m. Then our human ancestors appear on the scene at 11:55 p.m. On this scale, the Industrial Revolution was a mere hundredth of a second, and space exploration has only been taking place for 3/1000ths of a second. If we try to imagine this long process taking place on another planet, it is almost certain that the original life form will eventually evolve into an intelligent species. However, it is highly unlikely that it would lead to humanoid beings. Unlikely, but not impossible. Michio Kaku is a professor of theoretical physics at the University of New York.
Exobiologists, that is, biologists that look for perhaps intelligent life forms on other planets, say that there are really 3 ingredients for intelligence, just 3. First is the ability to have some kind of language, culture, to be able to hand down communication from generation to generation. Second is a hand of some sort, a way to grab a tentacle, perhaps a claw, fingers, to manipulate the environment. And the third, eyeballs of some sort, some way to sense the environment. But that's it. Eyesight of some sort of grappling instrument, and some sort of culture, communication, language. Beyond that, anything goes. Look at the animal kingdom on the planet Earth. There are many animals that could, given a few million years, probably become intelligent. Octopus, for example, they have tentacles. Lobsters have claws. Mammals, if they had opposable thumbs, they would be able to manipulate the environment. Just on the planet Earth, we have a fantastic variety of animals without 2 eyes, nose, mouth, ears, chin, forehead in the exact proportion of a human. Therefore, when I see a picture of an alien that looks just like us, I tend to think that these are simply memories of 1950s science fiction movies when we saw bug-eyed monsters. Even on the planet Earth, the diversity of life forms is fantastic compared to what we see in science fiction movies. I would be more convinced if I saw an intelligent octopus or intelligent lobster. I would really be quite impressed if somebody says they were abducted by an intelligent octopus.
If anatomical shapes are infinite, then what about intelligence levels? Can you imagine what an extraterrestrial civilization 1,000 or 10,000 years ahead of us might be like?
We physicists believe that when you look in outer space, we have type 1, type 2, and type 3 civilizations. A type 1 civilization is perhaps 100, 200 years more advanced than ours. They control planetary energy, anything involved with the planet, the weather, perhaps earthquake and volcanoes, they can control. However, eventually, they expand by a factor of 10 billion to have the power of a star. They control solar flares, a type 2 civilization. A type 2 civilization can roam across parts of the galaxy. They have the power of thermonuclear fusion, the power of stars themselves. Eventually, they exhaust the power of a star, and they become galactic. They become type 3. They have tremendous accesses to huge, vast regions of our galaxy. A type 2 civilization is 10 billion times more powerful than type 1. A type 3 is 10 billion times more powerful than type 2. But on this scale, what are we? We are type 0. We get our energy from dead plants. We can only speculate what it would be to be like a planetary civilization, to be able to energize volcanoes and earthquakes and change the weather at will.
If such civilizations exist in the universe, what do these beings look like? And how can we detect their presence? In the early 1960s, anxious to obtain an answer to this question, scientists set up an ambitious project designed to listen to space. It was called Project SETI, Search for Extraterrestrial Intelligence. The idea was to use radio telescopes to listen in on the interstellar void, in the hopes of picking up a radio signal of alien origin. Here on Earth, we use radio waves in practically all forms of communication. If extraterrestrials were living on a planet orbiting the star Zeta Reticuli, some 30 light years away from Earth, and doing the same experiment, they would just now be picking up old episodes of Hawaii Five-0 or The Invaders. SETI researchers had to choose a specific wavelength to listen in on. For convenience sake, astrophysicists decided to choose a wavelength that was equivalent or close to that of hydrogen, the most common element in the universe. So they chose 1420 megahertz. Since then, space has been hopelessly silent. Apart from a few abnormalities, like the signal picked up on August 15, 1977, which was dubbed the WOW signal, Project SETI has not recorded any signals that could be indisputably interpreted as a message from alien intelligence. The apparent failure of Project SETI has led several scientists to conclude that there are no advanced civilizations anywhere in the cosmos, a conclusion that some feel is a bit premature.
Many scientists look at the SETI program and they say, see, we've scanned the heavens and we see no evidence of any intelligent life in outer space. Well, I don't think so. I don't think that perhaps in the next century we'll find any usable signal from outer space. First of all, we've only scanned perhaps 100 light years from the planet Earth in some detail. Our galaxy is 100,000 light years across, and galaxies are tens of millions of light years distant. So we've only scanned a small neighborhood of our galaxy. Second of all, we've only looked at frequencies near the frequency of hydrogen. That's silly. This goes back to the person who lost his key. A person who drops his key will often look next to a lamppost. But if you say to the man, why are you looking next to a lamppost? You dropped your key over there. The person will say, well, that's where the light is. There's no light over there. Therefore, I will look over here. We look at hydrogen frequencies because they're convenient. However, scientists don't think that these aliens will communicate at hydrogen frequencies. Perhaps they use laser technology. We've only barely begun to scan other frequencies. Therefore, we have to look at the broadband. Also, when you communicate across vast distances, we sometimes take a signal and chop it up. And then we send each piece, and it reforms at the other end. That's how the internet works. Email is chopped up, sent through various cities, and is reformed at the other end. But if you were to intercept one fragment of email, you'd get nonsense, gibberish until it's reformed. Therefore, in outer space, they probably send signals not on one frequency, but perhaps on the entire spectrum, so that a passing star will not interrupt the entire signal. Then at the other end, they reassemble the signal. If you were to listen in on their signal, you would hear gibberish, nonsense. In other words, we could be in the middle of an intergalactic conversation and we wouldn't even know. Our technology is so primitive, we look on simply one frequency. Any advanced civilization will send messages across all frequencies in order to compensate for passing stars, passing stellar explosion, and static and interference. That's real science. However, scientists sometimes judge alien technology on the basis of what we can do, not on the basis of what a Type 3 civilization, millions of years more advanced than ours, can do.
A lot of UFO followers find scientists' attitudes to be somewhat of a paradox. On one hand, efforts are being made to listen to space in the hopes of picking up an alien signal. And on the other hand, scientists do not seem to be particularly interested in the UFO phenomenon. From an objective point of view, we must admit that there has been no solid proof linking this phenomenon to visits by extraterrestrials. But the theory is still valid. Unfortunately, too many scientists continue to view this theory as nothing more than a popular fantasy. To defend their view, scientists cite the Fermi paradox. 50 years ago, Nobel Prize winner Enrico Fermi, an Italian physicist, a friend of Einstein, once said, "If there are extraterrestrials, where are they?" In asking this question, Fermi wanted to point out to his colleagues that if life was as widespread in the cosmos as they believed it was, then it was reasonable to think that civilizations far more evolved than us existed. According to Fermi, several of those civilizations should be technologically advanced enough to visit us. By Fermi's logic, given the fact that extraterrestrials have not yet landed on our planet, it must mean that they don't exist. This rather radical statement became known in scientific circles as Fermi's paradox. From there, it was only a quick leap to say that people who believed they had met extraterrestrials were delusional.
As for the credibility of a witness, or the assessment of a witness's credibility, Enrico Fermi's name was often mentioned, saying, "Listen, if extraterrestrial beings had visited us and were among us, we wouldn't be sitting here discussing it. It would be obvious." We need only look at the example of Europeans arriving in North America in the 15th and 16th centuries. It didn't take years for news to spread to the West Coast that ships had arrived in the Gulf of St. Lawrence. It would be the same thing in modern times. If extraterrestrial beings were visiting Earth, which is highly unlikely, then they would be on television. They're not that shy.
The problem with Fermi's paradox is that it considers alien visits in terms of our expectations and not reality. Extraterrestrials may already be among us, unbeknownst to us.
There is the famous Fermi paradox. That is, if there are extraterrestrial beings out there, then where are they? Well, take a look at this. Let's say we have an anthill in the middle of a forest. And right next to the anthill, they're building a 10-lane superhighway. And the question is, would the ants be able to communicate or understand what a 10-lane superhighway is? Would the ants be able to understand the technology, the intentions of beings building a 10-lane superhighway right next to the ants? Let's say, however, you go down to the ants, and you say to the ants, I bring you trinkets, I bring you beads, I bring you knowledge, I bring you nuclear energy, I bring you DNA technology, I bring you utopia, take me to your leader. Is that what you say when you bump into ants? No. Most people simply step on a few of them. Now, if we are really a type 0 civilization, and beings of a type 3 civilization can soar across hyperspace, they are perhaps millions of years more advanced than us. The distance between us and ants would be the same comparable distance between type 3 and a type 0 civilization. In other words, we are so arrogant, we're so conceited, that we say they must visit us. We're so important that they're going to interrupt all their business just to come to us and give us a little bit of super technology. I don't think so. Again, ants looking at a 10-lane superhighway, they would first of all not even know what a highway is. They would not be able to detect the presence of the highway, understand their communications, and even if they did, would the ants say, why don't they visit us? Why don't they come and bring us this fantastic technology of ours? I don't think so.
Other than the question of perception, scientists point to physics-related problems to disprove the theory that we are being visited by extraterrestrials. Their main argument, of course, is the expansive distances that separate the stars, which seem at first glance uncrossable, even traveling close to the speed of light.
In physics, we have something called the giggle factor. That is, anyone talking about UFOs will find themselves drummed out of the scientific community. UFO research is the third rail of science. Any scientist who dares touch UFO research finds their scientific career electrocuted. However, I think we have to look at the long-term perspective. Many scientists say the stars are so far away, hundreds, thousands of light years away, that any intelligent being would take thousands of years to reach the Earth, making it impractical. I think that's a mistake, because we assume that these extraterrestrial beings are only 100, 200 years more advanced than us. Then that's a problem. Einstein said that the speed of light is the ultimate speed limit. You cannot go faster than the speed of light. That's Einstein's special theory of relativity. But you see, we have to go beyond Einstein. We have to go to the general theory of relativity, where it is possible, we think, that you might be able to go faster than the speed of light. And even beyond that, to the quantum theory, to the unified field theory, in which all bets are off. So I think that the fundamental mistake that many scientists make is that they assume that extraterrestrial beings are only 100, 200 years beyond our civilization, not thousands, millions of years beyond ours.
What if extraterrestrials do not come from another planet, but rather from another dimension that we are unaware of? A sort of parallel universe out of our grasp. 5 years ago, such a concept would have been considered ludicrous. However, with the discovery of quantum physics, our vision of the universe is changing.
When I was a child, I used to go to the Japanese tea garden in San Francisco, and I used to look at the fish, the carp, swimming in a shallow pond. I used to go down and look at the fish and wonder what would it be like to live in 2 dimensions. These fish could only move forward, backward, left, and right. And I imagined what a strange universe it must be. The concept of up into the 3rd dimension was alien to them. I could put my nose right next to the fish, and they would never know that there was something called hyperspace. Today, many physicists believe that we are the fish. We move forward, backward, left, right, up, down. And we say that's all there is. What you see is what there is. However, we now believe that there is a theory of everything that will allow us to, quote, read the mind of God, as Albert Einstein would fondly say. We think that there is a higher theory called M theory that exists in 11 dimensions where we have strings and membranes that pulsate. And we now believe that our universe is nothing but a tiny bubble, a bubble floating in a much larger hyperspace. In other words, cosmologists don't really believe in a universe anymore. We believe in a multiverse, a megaverse of bubbles that are constantly springing into existence, expanding like in a Big Bang. So in other words, our universe may coexist in an ocean of other universes. Now, 5, 10 years ago, this notion was considered bizarre, science fiction. Not anymore. In the last 5 years, the data is almost conclusive. We have something called inflation. The fact that the universe expanded in many stages, one an extremely rapid stage of expansion. The only way to explain this rapid expansion is to assume that our universe is a bubble, coexisting with other bubbles in a multiverse, in a megaverse of universes.
Just one universe among so many others. It sounds like science fiction. But over the past few years, new discoveries have greatly reduced the gap between science and science fiction. Scottish genetic engineers cloned Dolly the sheep. American, British, and Dutch researchers succeeded in teleporting a photon, which is a particle of light. Obviously, we are still a long ways away from the famous Star Trek line, "Beam me up, Scotty." But we're already taking steps towards the teleportation imagined by Gene Roddenberry. What does the future hold? What will science be like in the year 3000? What might be the science of a civilization 100,000 years more technologically advanced than we are?
On Star Trek and many science fiction movies, we see an emerging Type 2 civilization. The Federation of Planets is Type 2. They have colonized a small fraction of our galaxy. However, they live in fear of a Type 3 civilization on their program called the Borg. The Borg are a genuine Type 3 civilization. They are galactic. They go between star systems within the galaxy itself. We physicists have looked carefully for Type 1, Type 2, and Type 3 civilizations in outer space. For example, a Type 2 civilization may have what is called a Dyson sphere. A Dyson sphere encapsulates an entire star. They are able to use the entire energy output of a star, which in turn is about 10 billion times the energy that is contained within a planetary civilization, a Type 1 civilization. We've looked for them. Even if they try to cloak themselves and hide themselves, they must obey the second law of thermodynamics. They must emit waste heat. In the infrared, we've looked for them. We've looked for the infrared signature of Dyson spheres in outer space. Unfortunately, at the present time, we have found no evidence of Type 1, Type 2, or Type 3 civilizations. But we physicists, when we look in outer space, we don't look for little green men. We look for civilizations on the basis of energy. Energy hundreds, thousands, millions of years ahead of ours. A Type 1 civilization is about 100 to 200 years ahead of ours. You can already see the beginning of it. The internet is the birth of a Type 1 telephone system. The European Union is the birth of a Type 1 economy. English and a few European languages are the foundation of a Type 1 language. A Type 2 civilization is perhaps 5,000, 10,000 years more advanced than ours, because growing at a simple 3% rate of their gross domestic product, they would attain stellar energy on a scale of perhaps 10,000 years. A Type 3 civilization would be perhaps 100,000 to 1,000,000 years more advanced than ours. My point is very simple. When we look at outer space, you cannot judge aliens by Type 0 technology. We assume that aliens are nothing but an advanced Type 0 civilization. However, once you attain Type 3 status, you have access to what is called the Planck energy. The Planck energy is 10 to the 19 billion electron volts. That's 1 with 19 zeros after it. That's a quadrillion times more powerful than our most advanced atom smasher. At the Planck energy, it may be possible to bend time into a pretzel, punch a hole in space, and leap into the 11th dimension.
Recently, a few astrophysicists proposed the idea of wormholes to explain the problem of crossing huge interstellar distances. In theory, these wormholes are like tunnels that allow passage from point A in the universe to point B using a shortcut. They are a pathway for interstellar travelers.
In Einstein's general theory of relativity, space-time is like a fabric, like a sheet of paper. And Einstein himself realized that perhaps the sheet of paper can fold on itself and give us a shortcut through space and time. In other words, take a sheet of paper. We all know that if I take 2 points, the shortest distance between 2 points is a straight line. However, we now know that's not true. The shortest distance between 2 points is a wormhole. That is, if you can rip the fabric of space and time, you could take a shortcut, like a subway ride through space and time. Now, Einstein realized this. We call them Einstein-Rosen bridges, bridges between 2 points in space and time. Most people know this as Alice's looking glass. Through the looking glass, Alice was faced with a mirror. She put her hand through the mirror, and her hand went to the other side of Wonderland. In Einstein's equations, we have many solutions, in fact, hundreds of solutions, in which we have Einstein-Rosen bridges. For example, take a look at a black hole. If I have a spinning black hole, the black hole does not collapse to a dot. It collapses to a ring of neutrons. This ring of neutrons forms the frame of Alice's looking glass. If you fall in between the ring, through the ring, then your hand may in fact go to the other side of the universe. Now, there are problems involved with wormholes. The main problem is stability. We're not sure if they're stable. We have to go to a quantum theory to calculate whether or not you could really make a journey through the black hole itself. However, I should point out that astrophysicists have now discovered about 30 black holes in outer space. All of them are spinning very rapidly, about 1 million miles an hour. And we do think that perhaps at the very center, there is a ring of neutrons, such that perhaps at the very center, if you go through the bullseye, you may go to perhaps another universe.
Are we being visited by aliens? According to the most recent statistics, close to 1 out of 2 Americans think so. If UFOs are linked to these visits from outer space, we can only marvel at their incredible discretion. History has shown that when 2 societies meet that are too far apart on the technological scale, chaos ensues to the detriment of the more primitive society.
Arthur C. Clarke once said, whether intelligent life exists in outer space or whether it doesn't exist in outer space, either thought is frightening. If we are the only ones in the universe with intelligence, it's frightening because we're alone. However, if we're not the only intelligent species on Earth, then we are also frightened because we wonder about their intentions. Think about what happened when Cortez met Montezuma in Mexico City. The Aztecs were perhaps 500, perhaps 1,000 years behind the technology of the West. Cortez had gunpowder, borrowed from the Chinese. He had horses. He had a technology centuries, perhaps 1,000 years more advanced than the Aztecs. The Aztec civilization, which lasted perhaps 10,000 years since the last ice age, collapsed in just a few months. That's what happens when 2 civilizations encounter each other, when one civilization is more advanced by perhaps a few centuries, but has malevolent designs. I think that if a civilization that advanced, millions of years advanced, more advanced than ours, were to meet ours, perhaps we would be ants to them. If a 10-lane superhighway were being built next door and there was an anthill next to it, what would the construction crew do? They wouldn't even give it a thought. They would simply pave the anthill away. My personal point of view is they're out there. In fact, many of my friends also believe they're out there. What divides us is the question of whether or not they can reach us, whether or not they can sail across millions of light years between different galaxies and star systems. However, most physicists believe in their heart of hearts, yes, they're probably out there. And when they do encounter us, I hope that when the encounter is made, an encounter of the third kind, that they are benevolent, that they are type 3, they are beyond planetary. At the present time, we are type 0. We have all the sectarian, fundamentalist, racial hatreds coming from the swamp. we are just barely out of the swamp with all the savagery of the swamp. By the time we're type 1, we will become interesting, civilized, a planetary civilization, capable of working out their differences, capable of being able to work out sectarian, nationalistic, regional differences. By the time they are type 3, they will have had perhaps 1 million years in which to sort out all their aggressive tendencies. So I think that if we do encounter a type 3 civilization in outer space, it won't be like the encounter between Cortez and Montezuma. Perhaps they will be benevolent. Perhaps they will see intelligent life forms as precious. The most precious commodity in the universe is consciousness and intelligence.
If extraterrestrial beings are visiting us, what do they want? What interest could they possibly have in a civilization as primitive as ours? Nowadays, quantum physics is showing us a universe that is much more complex and dynamic than we thought. We no longer speak of a single universe, but rather multiple universes. The speed of light is no longer an absolute value. It is a simple variable in an equation that is constantly changing. Scientists who have been discrediting UFO reports under the pretext that alien visits are nothing more than a dream must now re-examine their arguments. While the data gathered to date on UFOs does not conclusively support the theory of extraterrestrial visits more than any other theory, science has not managed to exclude this possibility either.
We're aware that interstellar visits would require tools and means far beyond any technology that we have here on Earth. We would have to examine quantum physics, reformulate the theory of general relativity, and consider the possibility of traveling faster than the speed of light. All of that is reasonable. I'm certainly not going to sit here and tell you that science has gone as far as it can go, that in 100 years or 1,000 years we won't know much more than we do now. So it's just a question of means. I think that if a civilization continues to survive and to develop over a long period of time, it will eventually discover the means of interstellar travel. The question is, do many civilizations exist? And do they have enough wisdom to continue to survive long enough to reach this point? Earth has already launched 2 Voyager probes, which are now outside of our solar system. And over the next tens of thousands of years, they'll be reaching stars other than our sun. We're capable of sending out a small plaque with a drawing of a man and woman on it saying, "Hi, we're here." Will it end up in the right place? It's doubtful. There's a very small probability of it happening. We're still not ready to build crafts capable of carrying an entire ecosystem on board for interstellar travel. Trips such as those would require extreme speeds, which we're thousands of years away from achieving. The ship would need to have an entire ecosystem, including agriculture. It would be a bit like putting Montreal Island into orbit, with its entire population, which would continue to reproduce. We're not there yet, but we might be someday. If we're still a viable civilization in 10,000 years, in human and technological terms, then why not?